Good morning, good afternoon, and good evening. Welcome to today's Lubrizol360 webinar. My name is Jen Bronner, and I will be the moderator for today's discussion. Before I introduce our presenters, I would like to take a few minutes to go through some housekeeping items. Today's presentation is scheduled to last for 30 to 40 minutes. During the presentation, your microphones will be muted. If you have any questions, you can submit them using the Q&A feature in WebEx. This should be in the right-hand side panel of your screen. You will only see your questions, and I will use these in the Q&A session after the presentation. I may combine similar questions together, and we may not get to all questions. At the conclusion of the webinar, you will be presented with a survey so you can provide feedback on today's event. And the recording and a copy of the presentation will be made available afterwards. I would now like to draw your attention to the following antitrust statement. Today's webinar is being presented by Lubrizol for the purpose of providing information and insight into the markets and applications into which our products are used. This may include how performance and/or end-user requirements for those products are changing and how our products perform against existing or future requirements which have yet to be formalized into performance specifications. As certain attendees participating in this webinar may be competitors of each other, we will be conducting this webinar in strict compliance with the antitrust and competition laws. For this reason, competitively sensitive subjects, some of those are shown on the screen, may not be discussed at any time, and any questions that are submitted that relate to the areas shown will not be asked. At Lubrizol, safety is the top priority of our organization, and we start every meeting by sharing a safety moment. This provides the opportunity to discuss and reflect on topics that can help ensure we all remain safe at work and at home. Today, we'll discuss sleep. Getting enough sleep has many benefits, including getting sick less often, staying at a healthy weight, lowering your risk for serious health problems, reducing stress and improving your mood, thinking more clearly, doing better in school and at work, and getting along better with people. Here are 13 tips to help you get a better night's sleep. Stick to a sleep schedule. Go to bed and wake up at the same time each day, even on the weekends. Exercise is great, just not too late in the day. So try to exercise more than 2 to 3 hours before your bedtime. Avoid caffeine and nicotine. The stimulating effects of caffeine can take as long as 8 hours to wear off fully, and nicotine is also a stimulant. Avoid alcoholic drinks before bed. Alcohol keeps you in the lighter stages of sleep. You also tend to wake up in the middle of the night when the sedating effects have worn off. Avoid large meals and beverages late at night. A large meal can cause indigestion that interferes with sleep, and drinking too many fluids at night can cause you to awaken frequently to use the restroom. If possible, avoid medicines that delay or disrupt your sleep. Don't take naps after 3 p.m. Naps can boost your brain power, but late afternoon naps make it harder to fall asleep at night. A relaxing activity, such as reading or listening to music, should be part of your bedtime ritual. Take a hot bath before bed. The drop in body temperature after the bath may help you feel sleepy, and the bath can help you relax. Have a good sleeping environment. So get rid of anything in your bedroom that might distract you, such as noises, bright lights, an uncomfortable bed, or a TV or computer. And keeping the temperature in your bedroom on the cool side can also help you sleep better. Have the right sunlight exposure. Daylight is key to regulating daily sleep patterns. So try to get outside in natural sunlight for at least 30 minutes per day. Don't lie in bed awake. If you find yourself still awake after more than 20 minutes, get up and do a relaxing activity until you feel sleepy. And lastly, if you continue to have trouble sleeping, see a doctor. So hopefully these tips will help you get 7 or more hours of quality sleep per night. I would now like to introduce our speakers for today, Mark Dewey and Keith Howard. Mark is a strategic technology manager supporting Lubrizol's strategic technology activities related to emissions. He has been with Lubrizol for 10 years and has spent numerous years working in the mechanical testing department, specializing in fuel efficiency and emissions testing. Mark is a chartered engineer with the Institution of Mechanical Engineers and has a master's degree in automotive engineering. Keith Howard is also a strategic technology manager supporting Lubrizol's strategic technology activities related to emissions. An automotive engineer by background, He has been with Lubrizol for 29 years in a range of roles covering engine oil development and approval, testing, and OEM-related activities. Keith is a chartered engineer and a fellow of the UK Institution of Mechanical Engineers. Today, Mark and Keith will be discussing Euro 7, and I will now turn it over to Keith.
Okay, thank you very much, Jen. Good morning, good afternoon, good evening to you, wherever you are, and thank you very much for joining us today. I hope you'll get something out of this, this short webinar. Mark and myself are going to give an overview. It isn't going to be in great depth due to the time, but we hope you'll find it useful. So if we start by looking at generally what is the goal of future emissions legislation, we are really in the age of increasing electrification of the global vehicle fleet. And with that in mind, legislators are setting the next generation of regulations to be as close to zero tailpipe emissions as possible. And you may be aware that there is increasing emphasis on other sources, especially for vehicles, tyres and brakes, and those are included in Euro 7. We're not going to cover them today. We're going to cover the fuel and lubricant relevant issues which are related to tailpipe emissions. So we're really talking about improving urban air quality mainly. That's the biggest issue with tailpipe emissions, tailpipe criteria emissions. And you can look at this, you can look at three dimensions to this. We want to keep the levels ultra low. So Euro 7 and future legislation will have very tight limits and will cover more pollutants. You want to ensure that those vehicles are clean under all operating conditions. So you will see wider test conditions, especially covering low temperature when traditionally emissions after treatment does not work as efficiently. And you'll also see technology neutrality. So previously, Euro 6 legislation had different limits for port fuel injected engines, for gasoline direct injected engines, and for diesel engines. They're all now harmonized with one limit, and that is a lower limit too. And we want the third dimension is the time or distance dimension. We want those emissions to stay ultra low for the full useful life of the vehicle. So we'll see the need for increased durability, increased emissions durability, increased checking of in-service compliance for a longer period. And we'll see increased use of in-use monitoring involving sensors to measure those emissions on the vehicle and record the data for subsequent analysis and checking that the vehicle is staying in compliance. So if we look at Euro 7, I'll give an overview of both the light duty and the heavy duty, and then I'll get into a little bit of detail about light duty before handing over to Mark. Euro 7 light duty, we have most limits are based on Euro 6E gasoline, so not stringent limits in themselves, but there are a number of reasons that I'll come on to why Euro 7 is much more stringent than Euro 6. A couple of new pollutants added. We have PN10. So PN10 is particulate number down to 10 nanometers. Currently, particulates are measured down to 23 nanometers when counting the number of them. So there are quite a lot of additional particles in the 23 to 10 nanometer range. So that's important. And also we have ammonia added as a pollutant. There are wider RDE conditions and there are no conformity factors. So I will cover the meaning of that shortly. Also, we have extended in-use compliance, a doubling of that with the use of onboard monitoring. And in terms of timing, there is a 3-year kind of gap to allow the technology to be developed and implemented, and type approvals will start to be applied from 2025. And as in the banner there, it's really the slightly softer approach for light duty is about the limited light duty ICE lifetimes. Tight Euro 7 limits will be costly and would not have a particularly big impact on overall air quality, considering the limited time left until those ICE bans come in 2035. An overview of the heavy duty side. Differently, a kind of medium severity approach has been taken here, so the limits have reduced, and there are a number of additional pollutants added, PN10 and ammonia as per the light duty, but N2O, that's nitrous oxide, NMOG is non-methane organic gases, and HCHO is formaldehyde. Formaldehyde is an irritant to the airways, so that's been added. There will be, on the heavy duty side, more focus on RDE, because traditionally it's largely been used, compliance has largely been assessed by testing engines rather than vehicles, because of the nature of the range of vehicles. But now more emphasis on RDE, again with wider conditions and no conformity factors. An extended emissions durability from 700 to 875,000 kilometers, and a 2-year delay from the light duty legislation. 2027 is when the heavy duty legislation will be applied. So again, in the banner, HD internal combustion engines have a much longer predicted lifetime. There isn't the ease of electrification as there is with light duty. So, and also heavy duty vehicles are responsible for an undue amount of NOx, oxides of nitrogen, that needs addressing. So this legislation is quite tight on NOx as well. So let's look in a little bit more detail, light duty, about the limits, the legislation, and what the impact on the hardware will be. So we have the, you could say, softer approach that of taking Euro 6e gasoline limits as the baseline. That's why that top left circle is in orange. But there are a number of other reasons to say that really Euro 7 is a significant upgrade in emissions tightness, if you like. So we have technology neutrality, as mentioned. So previously, diesel engine limits for NOx, for example, were higher because diesel engines produce more NOx. So a concession was given, but now that will not be the case. We also have port fuel injected engines and GDI engines treated in the same way. That's important because previously only GDI engines had the particulate number limit applied. So now that applies to port fuel injected gasoline engines as well. That will mean a much wider adoption of particulate filters. So pretty much every vehicle, be it gasoline, GDI, port fuel injected, diesel, everyone that is sold in Europe will have a particulate filter on. The dropping of RDE conformity factors. Conformity factors are applied to RDE results to account for the lower accuracy of the portable emissions measurement systems, the PEMS, and that was anything between around 15 to 50%. That's been dropping over the successive pieces of legislation, but they're now gone altogether. So in effect, that means the limit is much tighter because it was the RDE measurements rather than the in-lab measurements that were the tightest benchmark. The extended emissions durability, we'll speak about that in a moment, and the change from PN23 to PN10. So a lot of additional particulates in that 23 to 10 nanometer range. And importantly, as we'll find out later, many of those come from the lubricant. And the wider RDE conditions, so particularly low temperature, and this will be an issue for diesel, and we'll talk about some of the hardware implications for diesel in a moment. So in terms of the actual limits, here they are. The vehicles to which these limits apply, they are cars up to 8 seats, so that includes minivans basically, and goods vehicles up to 3.5 tons. So your typical panel vans that do light goods delivery duties are subject to the light duty limit. So pretty much anything that you can drive on a regular European car license is subject to Euro 7 light duty limits. You can see there are two sets of limits there. There are ones for the standard RDE testing, and those are quoted in milligrams per kilometer. So we have limits for NOx, oxides of nitrogen, particulate matter, and particulate number. Both of those. The particulate number is by far the more stringent criteria of those two, particularly now that we're talking about PN10. We have carbon monoxide, which we know is poisonous. We have total hydrocarbons and non-methane hydrocarbons, so smog-forming material as well as lung irritants, and we have ammonia, and ammonia can be formed as a kind of byproduct of the catalytic conversion process in gasoline engines. So and it is known to be an irritant. So for the first time, that is limited in light duty legislation. You can also see that there's a second line of limits that are quoted in milligrams per trip. So this prevents a vehicle being very dirty, if you like, at startup, and then those limits being averaged out by the vehicle being very clean during the rest of the cycle. That's important because the emissions, you know, as you may know, emissions are dominated by those first couple of minutes of a trip when the engine's cold and when the after treatment's cold. The combustion's inefficient, the after treatment hasn't reached its light off temperature. So that 10-kilometer trip budget must not be exceeded. The in-use compliance requirements are doubling in both distance and time. So from 100,000 kilometers or 5 years to 200,000 kilometers or 10 years. So that's a significant increase. And not only is the duration and distance increase, but the monitoring is going to be much tighter. So Euro 7 cars must have onboard monitoring. Currently, there is, rather than OBM, there is OBD, onboard diagnostics. So that will just flag up via a warning lamp on the dashboard if the emissions control systems are not working properly. There won't be a record of exactly what emissions have been, what pollutants have been emitted in service. That will change, so there'll be lots more sensors involved, and that will enable the in-use compliance to be verified and also to flag problems. So that verification will ensure that vehicles stay clean. If they don't, that data will be compiled, and if particular vehicles are found to be non-compliant, particular makes and models, there will be consequences for the manufacturer. So let's have a quick look at what the implications could be for the hardware. In terms of the engines, the gasoline direct injection engine, GDI engine, will continue to be the core technology for the gasoline fleet. A key thing here is that gasoline particulate filters will be universal due to this technology neutral approach, and potentially they'll need to be more efficient to provide that high level of filtration right from the start. Filters usually actually improve as they age because the particles that are caught in that actually enhance they make the pores smaller within the filter, and they actually enhance the filtration effect. In the longer term, that can lead to blockage and problems with engine performance. But they must now work pretty much from the start, and they must work down to PN10. So changes to particulate filters. In terms of diesel, it's going to be NOx that will be the key. NOx control, particularly low temperature NOx. So what we're going to have to do is close couple those catalysts, those NOx reduction catalysts, and potentially electrically heat them as well. Now, close coupling is important in terms of contamination, lubricant-related contamination, because if you put the NOx reduction catalyst up close to the engine outlet, to the turbocharger outlet on the exhaust side, where it is where the gases are very hot, you have very hot gases with contaminants from the lubricant in there. So that could mean a reaction that will effectively poison that catalyst, and it being located very close to the exhaust outlet, that will accelerate that poisoning effect. Particulate control during diesel particulate filter regeneration could be significant. Previously, regeneration was not taken into account during emissions tests. Now it will be. So regeneration is basically happens when all the soot that has been collected in that filter needs to be burned off. So it may happen naturally if the engine's working hard and the exhaust temperatures are high. If not, there will be an injection of additional fuel to raise the exhaust temperature and burn that soot off. But that produces a spike in the emissions, so that will be taken into account. That could affect filter design. And we will see for all of those engine types, we will see increasing hybridization. So driven by the need to reduce CO2 and to improve fuel economy, increasing hybridization across all vehicle types, be it mild hybridization or full hybridization. So there you have an overview of effects on light duty hardware. So I'll now hand over to Mark, who will go through the heavy duty and continue on to give the summary. Mark.
Thanks, Keith. Yeah, so like Keith says, I'm going to talk to you about the heavy duty side of the new Euro 7 legislation. As Keith mentioned at the beginning, there's sort of three main focus areas for Euro 7. You've got the ultra low emissions, improving air quality. You've got extending it over a wider range of operating conditions, and then you've got the encouragement to increase the emissions durability. So you know the useful life of those vehicles is met with the emissions durability to be a much higher level, and that's read down quite well into the heavy duty environment, as ICE powered heavy duty vehicles are going to be around for a lot longer. It's going to be the most predominant power source for time to come. All three of these focus areas have been improved for Euro 7. So first of all, in comparison to Euro 6, all the pollutants that were listed in Euro 6 have been rolled over into Euro 7, but with much lower limits. There's also been the introduction of new pollutants with limits. There's been the change from particulate number 23 down to particulate number 10. The way in which the emissions limits have been stated has also changed. So this is to encompass that overall operating conditions. So as Keith mentioned at the very beginning, the heavy duty emissions legislation is moving from a engine testing environment into a real driving emissions requirements. So the Euro 6 legislation for emissions was written based on the duty cycle that those engines were operated in. So that was the World Harmonized Transient Cycle and the World Harmonized Steady State Cycle. And there was emissions limits for both of those. So one for WHTC and one for WHSC. With the move to in-vehicle testing, those emissions limits have been replaced by emissions limits that are appropriate to the temperature of the vehicle, or of the engine particularly. So you've got a cold emission limits requirement and then a hot emissions limits requirement. There is also one put in there for idle, but that's slightly different. Like I said, there's also more emphasis now on RDE testing, so moving away from that engine testing to that real driving emissions testing. And that RDE is a much broader range that will be classified as a valid emissions test than previously in Euro 6. So things like a broader range of ambient temperatures, a broader range of altitudes and loads. And then you've also got that extended emissions durability. So to closer represent how the useful life of these vehicles, that emissions durability has been increased. So it's much closer to the average useful life of the vehicle. So to ensure that the emissions levels are met for that entire life frame. So these are actually the limits. So just to clarify, heavy duty covers any vehicle of more than 8 seats in terms of a passenger carrying vehicle, and then a goods vehicle that exceeds 3.5 tons. And in that table there, you can see the cold emissions and the hot emissions. Both of those are listed as milligrams per kilowatt hour. So that is the milligrams per unit work done of the engine. The only exception to that in that table is particulate number 10, and that's a count. So rather than being a milligrams per kilowatt hour, that's a count per kilowatt hour. At the bottom there, you can also see a trips requirement as well. So similar to light duty, if the trip duration is less than the equivalent of 3 WHTC, so World Harmonized Transient Cycles, then there's a requirement for milligrams per trip rather than total for per kilowatt hour. In the table, you also notice there is the new pollutants listed. So you've got non-methane organic gas there, ammonia, nitrous oxide, and formaldehyde. In terms of emissions durability, that's split down a little bit further than just covering all of heavy duty under one emissions durability, and it's down to the size of the vehicle. So first off, any goods carrying vehicle under 16 tons in weight and any passenger carrying vehicle under 7.5 tons of weight has increased from 300,000 kilometers in 6 years for Euro 6 to Euro 7 being 375,000 kilometers in 8 years. For the bigger heavy duty vehicles, so any goods carrying vehicle over 16 ton and any passenger carrying vehicle over 7.5 ton, that's gone from 700,000 kilometers in 7 years to 875,000 kilometers in 15 years. So you can see there how that's much closer to the useful life of those vehicles. So what's actually changing in the heavy duty world to meet these Euro 7 requirements? Well, there's going to be an increased complexity in the after treatment systems. So if you look at the diagram at the bottom of the slide, you've got what could be a typical representation of a Euro 7 after treatment system. If I draw your attention first to what's inside that grey box, so the insulated box, you've got the diesel oxidation catalyst, you've got the DPF, the particulate filter, and then the SCR and ammonia slip catalyst at the back end there. That's typical of what a Euro 6 vehicle would have installed in the exhaust stream, but away from the engine. So it's usually mounted on a truck down on the chassis rail a little bit further away. But with Euro 7, there's going to be the addition possibly of this close coupled SCR for NOx control, particularly at cold temperatures. So to increase the temperature of that system, that's going to be close coupled to the engine to try and get some residual heat out of the engine as quickly as possible. Or it could be electronically heated. But that addition of that close coupled SCR close to the engine means it's much more vulnerable to contamination because it's first in the exhaust stream from the engine rather than being post the DOC and DPF. There's also potentially going to be some improvements around the diesel particulate filter, similar to what Keith mentioned in diesel light duty vehicles. But there's the requirements, because Euro 7 will include that regeneration phase in any valid test program for emissions limits, may need improved filters, but it may also require changes to the regeneration strategy from the engine to control that. So how the engine control system deals with those regenerations and when. Now, not everything can come from improving the after treatment systems to meet Euro 7 requirements. So there's potential for hardware changes to reduce engine out emissions to begin with. That's all around possibly trying to get the engine up to operating temperature quicker, and then to sit at a much more efficient state for longer. Such things as cylinder deactivation may become more prevalent in the heavy duty environment. And then there's also the addition of that advanced onboard monitoring. So yeah, again, similar to the light duty vehicles, heavy duty has had onboard diagnostics for a long time, where it just identifies that there may be a problem. Now we're looking at actually monitoring larger sets of data to make sure it's staying within its requirements. So that's a little bit about how Euro 7 has changed for both the light duty and the heavy duty. But how can the fuels and lubricants impact emissions of Euro 7 vehicles? So first of all, I'm going to focus on it from an engine oil's perspective, and the effect engine oil can have on particulate number emissions. So you've got two graphs here, both showing the size distribution of particulate number over one WLTC cycle, so the World Light Transient cycle for passenger car or for light duty. The top graph, you've got a low ash, low volatility oil, and then the bottom graph, you've got a high ash, high volatility oil. And straight away, you can see that the high ash, high volatility has a much higher concentration of particulate number. So the curve is much higher up the scale compared to the low ash, low volatility. But the thing to really draw your attention to is those two dashed green lines. So previously for Euro 6, the Euro 6 legislation was anything from particulate number 23 larger. So from the 23 dashed line there to the right of the graph, it included all of those particulate numbers in the emissions limits. But now moving to PN10, the limit's going to be set much lower. So anything from the right-hand side of that 10 dashed line is included. And you can see between that 10 and that 23 area, the amount of particulates that are actually produced that are contributed by a high ash, high volatility oil in comparison to those that are contributed from a low ash, low volatility oil. So really emphasizing the importance of running the correct lubricant. And that's not just at the beginning of the vehicle's life, but that's throughout the vehicle life to maintain that particulate number. What does that look like when it gets further down the exhaust stream? Because that's as an engine out impact. So obviously that's going to hit straight into your after treatment system. So that ash content will sit into the filters and cause filter blockage, which will eventually cause an increase in back pressure. So your exhaust back pressure will rise, which puts more or takes more energy from the engine. So therefore your fuel consumption will increase. There's also another slightly different aspect to this, and that's in terms of the lubricant components themselves. So if you look at things like phosphorus and sulfur, they can actually poison the catalytic coating on the after treatment system. So that poisoning affects the chemical reaction that takes place to convert the harmful pollutants into less harmful ones. So therefore reducing the effectiveness of the emission system. But that in itself can impact poor soot burn off, and therefore also increase back pressure of the exhaust system, and therefore increase your fuel consumption. Like we said previously, obviously the introduction of onboard monitoring means there's going to be a lot more sensors as well in the after treatment system, each monitoring a different pollutant at different stages during the after treatment or the exhaust flow. Now the lubricant may not cause or may not cause false readings in terms of adding to the emissions, but what they could cause is contamination of those sensors themselves. So fouling or dirting those those sensors will mean that the readings may be incorrect. So either forcing the engine to do something different, being that it's thinking that there is a high emissions resultant, or when you come down to having your vehicle inspected, it might throw up an error that way. And actually what you're needing to do is replace a sensor because it's been contaminated. So now I'm going to focus on a fuels related shift that could occur, also affecting particulate number. So on the image on the right shows the nozzle of an injector. So you can see how those nozzles are actually fouling, and the cleanliness is being a problem there from running a poor quality fuel. So you can see the nozzles are getting smaller, and there's that dirty deposit at the end there, and that's also within the injector as well, causing problems. So that fouling and that cleanliness problem will affect the performance of the injector. Okay, so affect the spray pattern, all sorts of things. So to maintain the power requirements during that set phase, the engine control unit will be increasing injection duration, so the amount of fuel being poured in, because it's not getting the combustion event that it thinks or it's requesting. So therefore increasing injection duration. If you increase injection duration, you're affecting your combustion timing, and that affects so many combustion parameters because you're reducing the window you have to have a combustion event, and therefore the temperatures that are going on, the brake thermal efficiency requirements, and therefore the emissions that you're actually producing from that combustion event. So the graph on the left there shows what a change in injection duration as a result of cleanliness problems has on particulate number. So you can see as injection duration increases because of that cleanliness decreasing and deposits forming on the injector, you can see how much more particulates are being produced. And what you actually want to do is run a high quality fuel that maintains the cleanliness of the injectors. So you sit at that most optimum position for particulate numbers and injection duration. So where those sort of orange data points are down the bottom, that's where the fuel system needs to maintain. So running a high quality fuel will mean it will sit in that optimum condition for a lot longer throughout the useful life of the vehicle, hopefully. So I spoke there briefly about two problems, both related to particulate number, but one from an aspect of lubricant and one from the aspect of fuels. But what are the other things that we must consider for fuels and lubricants for Euro 7 vehicles? I'm going to focus first on the blue circle there of points. So the first one being fuel economy improvement. So running a high quality fuel and a high quality lubricant in your engine can actually produce fuel economy or fuel consumption improvements by reducing internal frictions, by operating at better conditions for the engine. You can reduce the amount of fuel you're burning. So reducing the amount of fuel you're burning, making the engine operate more efficiently, will reduce the emissions that you're outputting. You've got things like fuel compatibility. So that goes back to that cleanliness thing as well. So making sure that the fuel system is operating its most optimum all the time. So making sure that all the injectors, fuel systems are clean and at the most optimum injection duration and things like that. LSPI mitigation. So LSPI is low speed pre-ignition, and there's several precursors that can be found in fuel and engine oil that could result in LSPI if it's of a poor quality. So LSPI is quite a common thing for GDI engines particularly. So with move towards Euro 7, the increase in GDI is going to be more. So therefore, making sure that you have a top quality fuel and lubricant will reduce those risks and those precursors that could result in LSPI, where you have catastrophic damage to the internals of the engine. Another thing certainly for light duty, like Keith mentioned, is the increase in hybridization. So that's where your plug-in hybrid electric vehicles are coming in. So you have the combination of internal combustion engine and electric power, so an electric motor, but that significantly changes the duty cycle and operating conditions of the engine itself. So the engine may spend a lot of time off where you're driving around on electric power, and then it starts up for a short period of time. So it starts up from cold for a short period of time and then turns off after it's charged the batteries or after that high power demand is over. And that in itself can induce a lot of corrosive properties into the internals of the engine because of things like condensation, fuel dilution that's not burnt off, because the engine is not operated at a high operating temperature for very long. And being able to account for that with a high quality lubricant is important to protect the internals of the engine. So that corrosiveness can't cause any damage to the internals of the engine. Next one around the corner there is deposit control. So that's the cleanliness of the internals of the engine as well. So making sure that there's not piston ring deposits forming or piston deposits forming, there's not sludge starting to block oil galleries and things, which are all going to impact the internal friction, the internal performance of the engine. And then finally, from an engine's perspective, you've got wear protection. So with these new Euro 7 vehicles coming in, the advancements in the hardware are going to be important. So making sure that the internals of the engine are protected for as long as possible from a wear aspect is critical to them operating at their best for the lifetime of the vehicle. So moving away now from the engine to the after treatment side, ensuring the after treatment meets the durability requirements for both light duty and heavy duty. Fuel and engine oils can have a big impact on that by minimizing those particulate number contributions, therefore minimizing that filter blocking, but also maintaining things like that NOx conversion efficiency, so you're not poisoning the catalysts and reducing their chemical reaction with any of the nasty pollutants. So in summary, Euro 7 will ensure low emission for vehicles for many years to come. There's slightly different emphases of light duty versus heavy duty. So light duty, moderate reductions, but then there's zero emissions requirements coming in 2035. So the focus is slightly different for light duty, whether for heavy duty, because the internal combustion engine is going to be around for a lot longer to power heavy duty vehicles. Those are more significant reductions for heavy duty. That said, for both heavy duty and light duty, there is significant challenges. So tighter limits for all of them, the technical neutrality that is there, and the additional pollutants that's been added all increase the challenges. There's also that wider range of operating conditions. So for a valid RDE cycle, compared to Euro 6, there is a wider range that a valid RDE cycle will apply to. So your ambient temperature windows, your altitude windows have all increased. And then there's that increased durability requirement as well. So that's to closer represent the useful life period of a passenger car or a light duty vehicle and a heavy duty vehicle. So making sure that the emissions equipment that's installed on that vehicle is maintaining that Euro 7 level throughout its useful life, not tailing off towards the end. And to achieve this, OEMs will be developing a range of solutions to meet Euro 7, and the fuels and lubricants will have an impact on these. So making sure that the use of high quality fuels and lubricants is there, but it's important for that full useful life of the vehicle. It's not just at the beginning. It can have a significant impact whenever it's changed to the wrong lubricant or the wrong fuel can have an impact. And I think from that, I'm back to Jen for any questions.
Thank you, Mark. Thank you, Keith. There so many questions came in while you were presenting. It was almost tough to keep up with them, but I think we have a good number of them that we can go through during the session here. And I will direct them at who I think is the most appropriate person, but certainly both of you are welcome to join to chip in as appropriate here. I'll start with the first one for Keith here. So how does Euro 7 legislation compare to other standards around the globe? Obviously, global audience here, so that's quite applicable.
Yeah. Well, I would say the key countries developing emissions legislation, or the key areas, it's Europe, it's North America, it's China, and it's India. So if we compare Euro 7 starting off with North America, there have been recent announcements from the EPA regarding the Clean Truck Initiative, and there's been a real emphasis on making those vehicles address NOx issues, oxides of nitrogen issues. So coming along in the pipeline are some tight limits for NOx, and importantly, low temperature NOx. We mentioned how important it is to control NOx at low temperatures. There are specific low load cycles and tight limits there. So similar and probably a little bit tighter in North America for HD when it comes to NOx. We'll see similar technologies developed, I think. When it comes to light duty, very few diesel cars in North America, so it's mainly about gasoline, and really a little bit behind, particularly on particulates. They still use a particulate mass measurement rather than a number measurement. Particulate number measurements haven't been adopted in North America, so the drive to equip the vehicles with particulate filters is not there to the same extent. So far fewer particulate filters. If we look east, and both China and India follow Europe with slight variations here and there, and are both currently at a Euro 6 equivalent. So no announcements yet, or no firm announcements about what they'll do after that, but it's fair to say that they are similar, but maybe I would say not as tightly enforced in many places, the limits in those eastern areas, but we can expect to see China and India developing Euro 7 equivalents in the longer term, maybe with variations, maybe hybrid between some of the North American legislation and European.
Thank you. That's a great summary of all the standards that are around the world and how they compare here. Mark, one for you. Why do we need to reduce particulate number emissions from engine oils, when vehicles have particulate filters fitted?
That's a very good question. So obviously what we're trying to do there is reduce engine out emissions. So trying to reduce it at source, so stop creating them rather than filtering them out. But also when you consider how the filter works, and also the changes with Euro 7, meaning regeneration is included as part of an emissions test. If you can reduce the amount of particulates that are being caught by the filter, you're reducing how much that needs to be regenerated, and therefore reducing the blockage. So it's far better, obviously, to reduce at source than try and capture, and it also improves that after treatment system as well.
That certainly makes sense, even to a non-technical person like myself. Another question back for Keith. Well, actually, either of you could answer this one. That are both light duty and heavy duty in proposal state, or have both been confirmed and approved?
Yeah, I can answer that. Basically, the legislation was kind of debated between experts up until the 10th of November last year, and then it was published, and now it's really in the state where it's talking about how it will be implemented rather than what the legislation is and what the limits will be. It's not finalized as such, but there is, I would say, very little scope for any alterations in the meat of it, in the limits or the actual conditions. So it's pretty much in its final state in that respect.
Perfect. And as things do continue to get finalized, obviously that's something we'll continue to share with folks as that progresses. So stay tuned on that. So Mark, a question for you. Will the SCR emission treatment system be present in Euro 7 diesel vehicles in the coming years? In the last year, it's been problematic due to the cost and shortage of urea/AdBlue. So will SCR systems be present in Euro 7 diesel vehicles in the coming years?
I think it would still be present in the purely because of what it allows the engine to operate in, having that after treatment system there. There may be more focus on how it's that urea is dosed in, because obviously ammonia now being a pollutant, being a measured limit, so there may be some more focus on the design around SCRs and the ammonia slip catalyst at the back of that, but I still see them being present in Euro 7 vehicles.
Okay, perfect. Thank you. So Keith, one for you. Just kind of current light passenger cars with after treatment exhaust catalyzed are under, for example, Euro 3 or Euro 4. Could they update to Euro 6 or Euro 7 just by changing its exhaust catalyzer to Euro 6 technology?
No, I think we're beyond the stage where you can apply retrofit. I mean, I used to be involved in a business that retrofitted emissions after treatment, but these days it is so integrated with the rest of the vehicle in terms of the sensors that are gathering information from how well the after treatment system is doing, and that is altering the engine's performance and altering the AdBlue injection if it has an SCR system and so on. So I don't think it's going to be feasible to upgrade by retrofitting an improved catalyst or filter from Euro 3, Euro 4 to up to current or future standards.
Gotcha. That's helpful to know. I think so, Mark. I'm going to try my best to direct you to the right part of your presentation where this question came in. But there was, on slide 23, you had a chart that looked at particulate number and injection duration. So the question came in just wanting to clarify if it was a diesel injector or a gasoline injector.
So that there, I'm pretty sure is a diesel injector.
Okay.
But the same could be said for gasoline. The principle is the same for an injector fouling point of view. It will cause problems with the combustion parameters. Okay,
perfect. Thank you. Good recall there on exactly where the presentation that was. So Keith, it appears we will see GPS being used across all light duty applications. Do you think the measurement technology will impact the potential use of higher volatility oils such as 0W8/12, or do you believe the GPS will be capable of handling a mist/aerosol of small particulate size oil droplets? Let me know if you need me to read that again.
No, I understand.
Okay.
I understand that, and that's something that we've looked at. Basically, I think it relates to the quality of the oil. If you have a good quality base stocks that aren't very volatile, you can push down the viscosity and not have an oil that is too volatile, so you won't see too much of the oil mist coming back through the breather system and then burned and producing particulates. And even if it is, it's important to minimize particulates at source if you can, because it does impact the after treatment. But in terms of the engine out emissions, the filter will still capture those particulates, whether they come from the engine oil or whether they come from the fuel combustion. They will keep the limits very low, keep the pollutants very low.
All right, perfect. Thank you. One back from Mark. So and I apologize, I don't remember exactly where in your presentation this came in. In the particulate measurement, are the biofuels better, either biodiesel and or HVO?
That is a good question. That is actually some work we're studying around with a local university. We are actually looking at the impact of different types of fuel on particulate numbers. So that's something we're investigating. I don't think I've truly got the answers to that at the minute, but that's something we want to look into and understand how that impact may differ with different fuels.
So again, maybe content that's coming soon. Oh, sorry, Keith.
Sorry, I could comment that you know, I used to work with diesel oxidation catalysts, and sometimes biofuels, because of their higher oxygen content, actually did improve the performance of diesel oxidation catalysts. But I think that difference is not going to be so great. Some, you know, HVO type fuels, some of the modern alternative fuels can be slightly better in emissions profile, but it's not huge. It certainly won't negate the need for the same type of after treatment.
Thank you for that. And again, even, you know, another area maybe where we'll continue to develop content as we learn more.
Mm-hmm.
Another question for Keith. So what kind of test cycles are suitable for development of RDE less than 10 kilometers distance for LDE? Any experience from European developments?
Well, RDE by definition isn't a cycle as such. It is getting in the vehicle and starting it and driving it, but then retrospectively making sure that the conditions in terms of the temperature ranges and so on, the load ranges have been met. So there isn't a prescribed cycle. There are cycles that's for compliance purposes, for compliance tests. There are cycles that are there for development, which is supposed to simulate those cycles, and there are a number of them. There's one called RTS 95, which is quite widely used, and that you can run that, you know, from a cold start, I think, and you can use that to simulate the initial warm-up emissions and get a feel for how well the after treatment is performing in under cold conditions.
Perfect. So we're a few minutes away from the end, but I think we can get to one, maybe two more questions, but we will see. So this one I think looks like could be addressed by either of you. So I'll let whoever wants to start go with this one. But is the silicon coming from an inlet system considered in the test for particulates? And this person is referring to cases with poor maintenance in the vehicles. Maybe more like that.
Well, yeah. First of all, silicon is coming from, you know, from the air intake. So if there's dust in the air, particularly if you're in a, you know, desert environment, in a dry, sandy environment, you can have an appreciable amount of dust in the air. That should be taken out by the air filter, but I presume the question is hinting that maybe the air filter has not been maintained and isn't doing its job properly. In that case, it can get in the engine, and it can cause wear, obviously. Things like if you're in a dusty, sandy environment, those particles coming through can cause wear. But if they go through the engine, they will be counted in exactly the same way as any other particulate matter, be it combustion-related particulate matter, particulates from whatever source. They will be counted by the PN measuring equipment and the particulate mass measuring equipment. So it will be treated in the same way when it comes to measurement.
Perfect. Thank you. And I think I'm gonna one more question for Mark, and then I think we'll close it out. And again, so many great questions came in that we can follow up with folks afterwards on those. Mark, for your last question here, is Euro 7 for HD going to use Roman numerals or to differentiate from light duty?
So that's a good question. So obviously, previously through all the other Euro legislation documents, the Arabic numeral was there for light duty, and then Roman numerals for heavy duty. But going forward with Euro 7, everything is going to have the Arabic numeral, just to reduce complexity, I think, of the documentation.
Okay. Perfect. Thank you. Yeah, that brings us right up to the end of our time here. Thank you again to Keith and Mark for the presentation. And again, so many great questions. Thank you to everybody for being so engaged in this topic. Once you close out of the session, again, just a reminder that you'll be presented with a survey, and we invite you to provide your feedback on the session. And we will also be sending and making available a recording and a copy of the presentation in the coming days here. But thank you again for attending, and enjoy the rest of your day.
Thank you. Some very good questions there. Thank you, Jen, for hosting it, and
Sure.
thank to the participants for some very good interaction there.
Yes, absolutely.
Thank you very much.
Thank you.